Alright folks, welcome back to the second part of the how to Torbjörn turret, right, from Overwatch in Unreal 4. So as I promised, in the first part we did all using blueprint, right? The second part we're going to do the same exact thing, actually slightly better, but everything is C++, right? So if we check here, everything is still the same. Now the ball will enter the volume, and the turret would aim at it, shoot it, and go back to its position, right? We actually slightly improved the barrel animation, so when it goes back to rest position, the barrels go to rest position as well, not just the head, right? And if we open the Torbjörn class, it sends us directly to Visual Studio, where we have, this is our code, that's what we're gonna write, right? And so in order to add a class, what you need to do is file new C++ class, or you can do it from here, right? You select what you want. In my case, it's an actor, and then you do next. It's going to ask you where you want to create, blah, blah. I already have my actor is a test class that I'm not using it. And it will create for you, it will boot Visual Studio, and you will start with an empty class, right? That compiles fine, so ready to be modified. So let's go right into the code, and let's see what we did here. So let's start from the header, right? So let's go here, let's make it bigger so you guys don't have problems seeing it, right? So those are all macros that Unreal Engine needs, right, to generate extra data for introspection, all this kind of stuff that integrates directly with the editor, right? So those are given for you. You don't need to worry about that. This is our name of the class. You see it's inherit from an actor class, so that's good. We have the constructor. So here we set initialize whatever we need to initialize. The two functions are provided to us already. So it's begin play, basically a function that gets called whenever the game starts. So any kind of initialization game specific, not like memory class specific, can be done here. And this is called every time the actor ticks. So every iteration of the game, if the actor says so. So if we say the actor, okay, we want to tick, this function is gonna get called. Those two functions are added by us. We're going to check that later why. And here the most important part of the header. Actually, we don't need that. We can get rid of that, right? So that's the most important part of the header. So here are all attributes that will show up in the editor, right? If you come from the Maya background, it's kind of like same Maya attribute of a node, right? And in order to define where or how you can edit them, you use another macro called uProperty. You can set to edit anywhere. It means that it will be visible in the editor, right? And we're going to create a lot of them, and let's see what they are. So the first one, child actor component, is just basically a root, the root of our child actor, so of our actor, right? And we call it the root. Then we have a U-shaped component, which is going to be a cube, which is basically the volume that you see in the viewport that's going to trigger us when stuff enter into the volume, right? Then we have a series of meshes that we want to spawn, and those meshes are what compose the turret, right? So we have a base mesh, so the legs, we have the hinge that let us twist, and then we have the head mesh, right? Then we have the barrels, same mesh components. Then we have a couple of other variables. So we have total animation time for the barrel, sorry. So how long it takes to do the full cycle. So recall back and go to rest position. We have recoil time. It basically says how long is the recoil only. Then recoil pose and rest pose, basically how far back and forth we need to move in our animation, right? We declare a private function for doing the gun animation, but we can look at that later. And we have a series of private variable, which we will look at them meanwhile we use them, right? So let's go back. Let's go actually not back, but let's go into the actual C++ class and Let's have a look about it. So in the constructor, first things I wanted to do, right, was to initialize our geometry, so our hierarchies and everything, right? So let's forget about this first part for the time being, right? And let's start from here. So first of all, we're going to set if the actor is going to tick and is going to set be true. This should be on by default, so if you don't need that to tick every time, you can set it to false and you will save some performance, right? Second, we need to initialize the root, right? So it's a uChild actor component, and you create one with a template function, create a default sub-object, and you pass the type you want to create between, I don't even know how they're called, the major and minor signs. They have a proper name, sorry, but let's call it pointy parentheses, sorry about that. And you just pass a name for it. So we initialize the root. And really important, we need to tell the actor which one is the root component, right? So we set this variable root component equal to root. And root component is defined in the base class, so we don't have to define it, it's come for us. That's how you initialize the component, right? And we do the same for everything else. So we do now for the volume. So we're going to create a uBox component, which is, as the name says, a box, and we call it volume. Now we want to attach this component to the root, right? So when the root moves, this follows. So this function signature has changed in the latest or in the more recent version of Unreal, at least in 4.12. I don't know about 4.13 that just came out. Might be different, but in this case, you pass the component you want to attach to, and you pass a set of rules that needs to be respected. In this case, the rules, which essentially a rule class, it might be a structure actually. It's a struct, okay. And we say that we need to we want to keep it like with keep relative transform, means it will behave as a regular hierarchy, right? And we just assert for the result just to be, a bit paranoid. We're in debug, so it's not much of a problem. Then we want to set just on the volume generate overlap events true. This means that it's going to generate events for every time something comes in the volume or gets out of that volume, right? And we define two functions. We are going to look at the details later. And basically, we set this function to be called every time on component begin overlap and on component end overlap. So let me rephrase that better. On component begin overlap, so it means when something gets in, we are saying, please call this function for me, which is start overlap, is a callback, right? Same goes for when it goes out, the end overlap. Why do we do that? Because basically, once we start overlapping, we want to say, hey, we need to start shooting. So we want to start aiming toward our objective. And once we go out, we say, hey, we don't want to shoot anymore. Let's go back to our starting position, right? Then just for debug purpose, I said set hidden in game false, so it gets drawn in the viewport. If you change this to true, it won't be shown anymore, right? So cool. Then we're going to set up our meshes. So we start with the base mesh. It's a static mesh, right? We give it a name. We attach it to the root same way. We check the result. And here we are initializing the mesh, so which mesh we want to have. But let's keep that for now, because it's part of the code as we skip it at the beginning. And we are going to do the same with the hinge. So we initialize the component, we attach it to the base mesh this time, we set the result, and then we set a relative offset. So why? Because when we create that, the hinge is at the origin. It actually needs to be shifted in the position it needs to be, right? That's, of course, it's not the proper way to do it. Again, I just want to get something going. This is the way I did it with the blueprint, which is the same thing. when we create the object in Blueprint, we were going to shift in position the stuff, and that's the same thing that happened. It's not a unique asset, right? Then we do the same with the head, same exact deal. We shift it, we instantiate and whatever. And same for the barrel. Once you do that, you can see in game, what you get is this. This is, you see, when we drop it, we have our geometries, right? And this is the hierarchy we get. So we get the root, volume and base mesh at the same level. Then the hinge is child of base, head is child of hinge, and the barrels are child of head, right? So whenever we move the parent, the children follow. Same exact thing. If we click on one of those, we see that it's already set up for us. So we have a static mesh and everything. That doesn't happen if we don't say set static mesh. Basically, here we need to say we want to set this specific mesh when we construct the object, right? That doesn't happen if we don't call that. And what we get, can we remove that? Can I reset? Yes, right? So when we create that without setting that, it becomes in like this, empty, and we need to get there, drag and drop. And this is tedious if you have to place many of them. So I wanted to initialize the mesh already because I know what I want, right? So what I did, I tried to find a way to spawn the geometry when I constructed. And the way I found it to do it is basically, you first, you need to create a finder, basically something that finds the specific kind of object you want. In this case, we're going to use construction helper object finder for its use static mesh, right? And once we have that, we want to pass the path, the relative path, to our object, right? How do you know this path? How do you know where it is? Well, the way I found it was you go into your geometry, you over it, and you get the path. You see, there is path down there. I cannot move my mouse, but it says /game/geo, and then the name through the base. And that's the same one I used, and it worked. So this is declared as a static. It means this is going to be created only once. You don't have to create it here. You can create it as a static member variable. I just follow an example that I found online. I just kept it that way. But this basically is going to be shared between all instances. So we create a finder. We check that it succeeds. It means, hey, did you find the geometry for me? Otherwise, it's going to assert. It's not so nice to assert in Constructor, but it was just, again, it's not production code. So I said, who cares? I just want to know if it finds my geometry, right? If it did, we have a pointer. We create a pointer for each of those meshes, and we set the base static mesh, which is a use static mesh pointer, equal to static mesh finder object. You don't have to do this. It's just a slighter smaller shortcut, so we don't have to write all this, but just static mesh. We do that for all of them, and then what we do is we do base mesh is a pointer, so we use the pointer notation, set static mesh, and we pass the pointer to the mesh, right? So this is good because, like, if you have many of those, we're going to reference always the same asset, right? Again, that's not how we do in production. I will probably do even statically in the outside the class, and then just reference it, right? But for sure, I will move that in the body of the class. But again, that was just an example I found, and to keep it simpler, I just put it here. So now we initialize everything. If you execute this, you're going to get exactly what we see here. Just if we press play, nothing happens. And now we're going to do the same exact thing we did for the blueprint, right? So this is the thick function. This is start overlap, end overlap. And then there's procedural gun animation. Let's start with the start overlap and the end overlap. If you remember, those are the callbacks that get called whenever something enters our volume. And we want to know about that, right? So first of all, this signature is specific. You need to implement this specific signature, right? Because that's what the interface demand, right? And so you declare that in your header, you can see it here, and you need to be careful. You need to mark it as a U function, otherwise the callback won't be called, right? It took me a while to figure out why my callback was not getting called. Everything was compiled fine, is for this. Make sure you have U function, otherwise won't get called. Not entirely sure why, I will probably dig into that, but you need to have that. So when we start overlapping, first of all, we're going to check if the class we are overlapping in, so other actor represent the object that's entering the volume. If it's a default pawn, we want to skip it, right? That's basically our camera. Because I had a bug where basically I was entering the volume just to moving around in the scene to see if everything was working correctly, and my turret would start looking at me. It took me a while to figure out, hey, that's because the camera is getting in, so it's starting to aim at the camera. So if that's the case, we don't want to. Of course, in-game, you would just want to filter for your specific object, like enemy characters or whatever, right? In case of Overwatch, it will probably be a player character. So if you only filter for that, if that's the case, we get out, we don't do anything. If it's not, if it's something else, we want to shoot at it. So we set the Boolean value, be should shoot equal to true. I'm kind of trying to follow somewhat a real naming convention where they prefix with the type. I think that's the Hungarian notation, something like that. Not entirely sure. But so basically this just means a Boolean, and it's declared in the header. You see it's a private variable, and it's initialized by equal to false. With C++11, which you can use with Unreal, I tend to initialize stuff in the header unless it's an input variable. If it's an input variable that you pass to the constructor, then I use the initialization list in the constructor. But this is a static value, so I just do it here and keep the constructor simpler. Next, what we're going to do, actually, we're not using the label, aren't we? Okay, so we actually can remove that. What we're going to do, we are going to save into actor pointer, you see with the curve here, the other actor, so we can keep track of it to what we want to shoot, right? That's all debug stuff, we don't need to see that. In the end overlap, we do the same thing, we check if it's the camera, and then we set to false, aim at equal to null pointer, and then this is for animating our gun, but we will see that later, right? So those callbacks are going to be called. Again, you can use some debug statement by doing including engine, then g-engine as screen debug message, right? And basically what you want to write. So this should be, if you want to override an existing message, in this case we don't want, that's how long it's going to stay on screen. That's the color, and that's the text you want to write. Let's just compile just in case to make sure everything's still fine, didn't break anything. So now let's start checking our fig function, right? First we say, okay, are we shooting? Okay, if we are, let's move forward. Let's do basically our aim stuff. Let's make sure we have something to aim at, something didn't go wrong, basically our aim at is correct. If it's not valid, we are going to get out, right? Here, not comparison works because it's a null pointer and it's defined, so we don't have to worry about that. But you can be more explicit and do like null pointer, right? Oops. This works just the same. Oops, sorry. So, but let's keep it the usual way. Now, this is all the blend stuff. For now, let's keep it. Let's make stuff simple. And let's only figure out what we need to do to aim, right? So we start by extracting the transform. So the head transform and the aim transform. So basically what we want to aim at, right? So our object that enters the volume. I'm going to go through this stuff slightly faster because the same exact thing I already explained in the blueprint. So watch that if you're kind of lost, right? So we grab the aim vector, so we subtract the translation part of the two, and we get an f vector, which is a float vector. Then we normalize it. Then here we are going to calculate just the hinge, so right, the twist amount. So we do the same thing. We kill the z part, so basically project on the horizontal plane. Again, this is a cheap trick. You should probably project properly on the hinge plane. But again, to keep stuff simple, then you find the angle, right, inverse of the cosine of the dot product, and then we find the orthogonal vector. We're going to build an orthonormal matrix, right? So we find a perpendicular vector to both the hinge aim and the aim vector. Again, recheck the blueprint stuff for making sense of this math. It doesn't. We normalize this vector, and then we normalize our up vector, right? So at this point, we have a rotation matrix which represents the twist of the hinge in an orthonormal matrix. So we go and build a matrix. In order to do so, we need to extract the translation part, and we are going to build a matrix using the four vectors that we need, right? It's a 4x3 matrix. And I'm going to negate the cross and the aim. And you might wonder, why are you doing that? Well, again, that's just because you can see our turret is aiming in the negative y, so we cannot use the aim vector directly. We need to flip it, and if we flip that, we need also to flip the cross vector. That's why. That's a specific problem with this. If you do that with bones, your life is slightly easier because you have a name bone. So a name axis for the bone is a convention. It can be X, it can be Z. It's up to you. But you know what you have to aim at. In this case, I need to flip in order to the turret to work properly. And so we have our hinge matrix, and we're done with that. So we're going to convert that to a transform, and to do that, we create a new transform, and we pass the metric. We can initialize a transform with a metric, which is great. Here's the blend part, so don't worry about that. We're going to see that later. But once you have your transform, you can just say hinge mesh set relative transform, hinge t, and we're good to go. All right, so that's all good and dandy. Now we do the same exact thing, but we do that for the head. So basically, how much up and down we want to aim. So we start by granting the translation of the head. Fine. We already have our angle, and we build a rotator out of it, right? So we know how much up and down we are aiming at. We computed this angle already. So we convert that to, sorry, we convert that to, sorry, I'm getting lost in my thought. We convert that to a degree from radians, so you multiply by 180 divided by pi, and we build a rotator out of it. So we can use that to build a transform using this rotator and this head. We're going to blend it, don't worry about that, and we set the transform, and we're good to go. Here we do the procedural animation of the gun. We're going to check that later. Here I'm just drawing some debug lines that is useful if you want to know how to do that, because basically those debug lines are going to be printed down on the bottom. Alright, that was super useful to basically visualize the matrix I was building, right? So you see it's an orthonormal matrix, it's really good. So I suggest you do the same. And the way it works is we pass the word we want to draw at, right? Then we pass a transform, sorry, a translation where the vector start, the line start, and where it ends. So we start at the head, But this is a relative transformation. That's why it happens 0, 0, 0, actually 0, 0, 10, something like that. Then we offset this point by the vector, and we scale that just to make it big enough. So we scale by 100, so we think it's a meter. Then we set the color. Don't remember what false is. I think it's the depth priority. No, it's persistent lines. So basically, if it needs to survive the render, but we want to that be animated, so we just want to persist one frame, so we set to false. That's the priority, that's something else, I don't know, and that's the thickness, how thick the line is. So I was drawing all three of them, and it showed the metrics, right? We do the same exact thing, basically, when we are not shooting. Basically, we want to blend back to the rest position. So we have the current position, right? So we get the relative transform, so we know where we are. We have the translation. So we are going to use the zero transform, so basically the matrix, not the form, the identity matrix, right? So that's what we have. So basically where we are not shooting, or you can use a specific matrix you want here. In this case, it's the identity. And we are going to blend. Don't worry about the blend, we're going to see that later. It's super simple. And we're going to set that. We do the same for the hinge, and then we need to reverse the barrel animation. So let's have a look at the blend, how it works. The blend works this way. Every time we are shooting or not shooting, we are going to manipulate the blend. So we have a step, right? Because we use basically using a fixed timestamp, something like that. Every time we shoot, we're going to increment that, right? And we're going to clamp it at 1. And so basically saying, okay, gradually shift toward the final aiming position, and when you get to 1, stay at 1, right? There's no point in going 2, 3, just going to freak out our metrics, right? So we increment. If we are greater than 1, we clamp it back to 1. And then we use this value to blend the transform, right? So we are going to blend from the starting position, the 0 transform, to the current matrix we computed, right? This means that a 0 value, it means we didn't move at all. 1, it means we get the 100% of the 8 matrix we computed, and that's the amount we want to blend between 0 and 1. Again, same exact thing we did in the blueprint. This is just through code. Instead, if we are not shooting, we are going to decrease this value, and we are going to clamp it at 0. So that's the value we use to blend here. So we are almost there. The code is pretty straightforward. Don't worry, I'm going to provide the code. And next, what we're going to do is the procedural animation of the gun. So let's have a look at that. So it's really similar. It's pretty much the same of the way we did in Blueprint. We declare a function that takes in the mesh component that we want to animate and a time offset, right? If you remember, the two guns are moving offset one from the other, right? And that's basically the offset we define. All right. So we grab the current time. In order to do that, you need to grab the word and then get the time in seconds, and then you sum the offset. If the offset is 0, it basically is like the offset is not happening. Now we are going to do the float modulus in order to divide the timeline into loops. And again, that's all explained in the blueprint. And if our current time in the loop is greater than recoil time, it means we are in reset. Otherwise, we do the recoil. So here, we are doing the reset. Here, in the else, we're doing the recoil. So here we want to know how much the reset length is. So it's the total time minus recoil time. You can probably compute that statically in the constructor. But again, to keep stuff simpler and compact in the same place and put it in here, then we want to know where in the reset time we are. So we have the loop, we subtract the recall time. That's going to be just the part inside the reset. So, and we are going to normalize that by the reset length. So here, normalized reset time is a value between 0 and 1 of the reset only. We are doing a linear interpolation. You can use a different interpolation if you want. So we are going to apply 1 minus the normal, so the blend value for the rest pose, sorry, for the recoil pose, plus the barrel rest pose. The resulting value is a float value that basically tells us where on the y-axis, I think it is, we are moving up and down. So we interpolated the recoil pose and rest pose, which we define it as an attribute the user can set, right? Once we have this value, we are going to grab the transform. We're going just to grab the translation. We set the translation the same for the x and z. We just set the new y position, and we set the transform back in, right? So we just grab the transform, we manipulate the translation, we set it back in. We do the same exact thing, but just for the recoil. So we grab inside the loop, we divide by recoil time. We don't need to subtract the recoil time because we know that we are here. Loop is less than recoil time, less equal the recoil time. So we know that dividing by recoil time is going to normalize it. We blend and we set the value the same exact way, right? We probably can actually take this out, right? And set it anyway once we compute position. And that's about it. We use the offset, so it offsets it out. And when we use it here, you see we're going to do the barrel mesh with 0 offset and the right barrel with 0.4. This value is basically just half the total animation time. You can even do that. You can just do total anim time divided by 2. All right, so we are offsetting by half a cycle. There we go. Let's get back to the normal code. And we're pretty much done. Only thing we need to do is that basically, once we are not shooting, right, what we want to do is to blend between the whatever position the barrel is at to the rest position, right? So we use this secondary blend value, which, if you remember, we set equal to 1 once we get out of the overlap, right? So this means that this is our blend value. So it means that when we get out, the whatever barrel position is 100%. Then this value is going to decrease all the way to 0. So it means we are giving more blending to the rest pose. And that's what we are going to do. So we grab the barrel, grab the translation, and we are going to linear interpolate, right, the current position to the rest pose, right? And then we set it back in. Same for the other barrel. So it doesn't matter where you are. It's going to blend down. And actually, if we go all the way to 0, it means that we don't have anything else to do. So we just return. We don't even compute this. You can keep it there. It's just going to do extra computation, does nothing. So I just get out. So that was a quick overview of the code. Again, if you mix this tutorial, if you add this tutorial to the previous one, everything should be plenty clear. I'm going to provide the code, and I actually forgot to provide the sourcing for the other. I'm going to provide that into GitHub repository for both tutorial, right? So that's it, guys. Hope it was useful. Any feedback is more than welcome. If you like it, subscribe and stay up to date with the channel. Share it around. See ya.